All right, guys, I want to give a quick update on the trash Fiesta because some people were asking me what happened to it. I posted up a picture of the engine out of it on our hoist here, and people were like, oh no, it blew up, blah, blah, blah. Well, it did blow up, but I have no idea what happened. I wasn't actually driving the car at the time. I had somebody dropping it off to me, and they showed up, and there was oil puking out the back. And car wasn't running right. It was down a cylinder. So I can make assumptions of what happened, but the failure is just kind of a common one with these engines. You know, the whole point of this car was to basically beat the shit out of it, and it was all for R&D. So we wanted to see what would fail, what we had to fix, you know, or what we had to address to make sure that it held together. For anybody that doesn't know, the trash Fiesta, basically it was a 100% stock engine, a Turbonetics S280 turbo, XDI fuel pump, Bosch upgrade injectors, E50, you know, bolt-ons, whatever, and it made 400 wheel horsepower, 400 wheel torque, and again, it's on a 100% stock engine. So, as you can see, the engine is out, and well, this is unrelated, but there's also not a dash in it. So we have the dash out because we're flocking it. For people that don't know what flocking is, that's basically, it gives you a texture to the dash to prevent glares. It's something that's done in like rally cars, so this is kind of going to end up being a rally car by the next owner. Oh, by the way, we're selling it. So dash is out. We're going to flock it. It'll kind of give it like a, I don't know, almost like an Alcantara look to it. So if you just look up any WRC rally car, you'll see what it is. So, but yeah, so the engine's out. I'll show you why and what we're doing to address the failure so it doesn't happen again. And this is something that we were planning on doing anyways, but we were going to do it on another Fiesta that I bought that I need to go pick up still. But I want to keep this thing together. It's super low mile, only has 1,800 miles on it, and I have one of my other customers that was interested in buying it, which he did buy it, but now he's just throwing a little extra on top because he's getting a built engine with it. So what happened? Well, let me grab a light, maybe, wherever Cody's lights are at. Oh, there we go. So, sorry, you don't want to look at my ugly mug the whole time, so we're going to look at some engine stuff. All right. I marked it, the cylinders, where the problems are. It's going to be hard to show on the GoPro here, but basically what we have and what the common issue is with these things is a crack in the cylinder liner. So that's number 3. Number 2 has a little baby crack. Hopefully it shows up on the camera. Like I said, sorry, it's GoPro, but it's right there. And then this one being the worst, number 1, which is kind of odd. Usually number 3 is the worst, but I guess, you know, when you're making that much power, the engine doesn't discriminate on what it's going to fuck up. So we got another crack there. This one's about 1/4 of an inch long. So if you look at the block, let me turn this light off. If you look at the block, this is a 1/6 block, the Fiesta. Hopefully that was clear. But anyways, these are slotted. Blah, blah, blah. So what happens here is the liner actually sits lower than the deck surface itself. So here's the deck. We got about, I'd say 3 millimeters worth. I'm just gonna get a little bit of light in there. You can kind of see the separation. So if you look at the top there, you'll see the dark cylinder liner, and then you see the actual aluminum of the block itself. So the 1.5 and the 1.6 in the Fiesta ST, the Fusion, the Escape, they all were slotted up until I believe 18. So, and the Fiesta ST just kept the same block. So what happens here is this slot actually allows the cylinder liner itself to kind of, I would say, oval out. It's really kind of describe a shape of it. It really doesn't make a shape. It just kind of pushes the liner towards this slotted part here, and it causes this stress crack. So it's, you know, it cracks this way. That's because we have zero rigidity up here with this slot, so that block's able to flex at the top. So when the piston's coming up, you know, and then you have combustion pushing it back down, there's a ton of heat here and there's a ton of pressure here. So these deflect basically. That's why you don't see any cracks on the opposite side. So all these sides are cracked. That one should crack, but because the most of the load is this way because of the way the engine's designed. You know, based on transmission side, you know, there's less load and stuff on one side versus the other. So you have the crank, always on any engine, you have crank that pulls one way. That's the whole point of a thrust washer, is to accept that force. But anyways, so there's no cracks on the opposite side. They're all on this side. So any other block that we're building, because we have a different solution, which I'll show in a second, this, to prevent it from happening, would require sleeves. So this would all be bored out by a boring machine, and then sleeves would be pressed in. So we do have a sleeved option, but we're still not going to use this block even when we do the sleeving. We might, you know, we kind of have to see how this goes. This is all the R&D process here, and we'll jump in that a little bit more, but this would need to be sleeved out. You can do like a partial machining, and then you could drop a thicker liner in. But what I would do is actually machine these all out, and I would actually do like a mid sleeve from Darton, and that would fill, you know, the gap all the way out to the outside of the block here. So that would eliminate the actual liner cracks, because there would be no liner at all when you're doing that. You have an entire sleeve that's going to be dropped in, you know, and basically at that point, the next weak spot is going to be more than likely the block. But this thing's actually pretty solid, and it's a really small frame too, so that actually helps out a lot. But this casting is way better than we see on these 2.0s and 2.3s. You know, you can kind of see this is, you know, a little rougher. This aluminum's really porous. On this one, where it's a hell of a lot smoother. You know, it's just a better block overall. You know, and this block, I mean, I haven't chopped one yet. This one's probably going to get chopped, or maybe another one I have. And the other Fiesta I bought is going to get chopped. But this, if I chop this, I imagine that the aluminum on the outside casting here is going to be fairly solid and, you know, not really porous. So moving on to what we're going to do for this car. So stock 1.6 block, 1.5 block. So this is the new revised block for the Fusion and Escape. There's probably another car that gets the 1.5T as well, but yeah, this is the new block. So Cody, my tech, which I hired, he worked at Ford before he started here. He's actually working on this thing right now, and he's not here because it's Sunday. But he goes, hey, you know, the 1.5 did the same thing. The 1.5 cracked on all the cylinders here. And I was like, he's like, there's an updated block. I was like, well, let's fucking check it out. So I ordered a 1.5 block, and sure enough, dimensionally, it's all the same. So I measured deck height on this. I measured the tunnel bore for the mains here. I measured the actual cylinder bore itself. And I took a couple other measurements too, and then I kind of looked at everything, you know, made sure that holes matched up. You know, this bolt hole is actually not used, but we have an intermediate shaft that bolts here. You know, we have the oil drain plug that go, or not the oil drain, but the turbo drain that goes here. And I just kind of set these blocks side by side and just compared them. There are some differences though, which we're going to get into, and some that I don't really think matter. This 1.6 is kind of, sorry, 1.5, 1.6. This 1.6 is used in different vehicles. So it has different bosses like this one here, which even on the Fiesta ST, this isn't used. And it's kind of odd because this is actually an oil channel behind here. That's actually a main feed for oil right here. So this isn't even used. And on this block, it doesn't exist. So you can see it's gone completely. And there's a couple other random holes that aren't tapped, but like I said, it's not used. And another thing that I did is I bought a 1.5 gasket, and I popped it on the 1.6 first, just kind of looked at it, you know, and then we put it on the 1.5, which obviously it's meant for that, you know, what have you. But then I lined it up to the cylinder head as well, sitting over there, lined it to the cylinder head, and made sure that everything's going to work, that we can put a 1.6 head on this 1.5 block. So, why are we using a 1.5 block? Well, let's have a look. Not slotted. These are cross-drilled. This is something that the 2.0 and 2.3s did as well. The 2.3s in the Ecoboost Mustang used to be slotted, and they changed to a cross-drill design. So if I actually pulled that cylinder head off, which it will be, but you can check any of my other posts. I posted our built engines for the Focus RS, ST, and Mustang before, and you can see the different deck designs, but that switched to cross-drilled, and that's actually something that caused head gasket failures in this thing, and that was unrelated to the actual block change. It was more related to the head gasket that they used. So, coming over here, we got crossrail design. We no longer have the slots here. So this is going to give us a ton of rigidity at the top of the block here. Another thing that I did is I actually measured the sleeve thickness. And now I don't have my caliper here. I wish I did, but I measured these sleeves, and kind of visually, if you look at them, you can kind of tell these are a little bit thinner. I mean, you probably have to be here, but you're not invited. These are 1.12 millimeters thicker, the sleeve itself. We still have a liner design, so there is a liner in here. Sits below the deck still, but where that crack happened on the other block, I highly doubt it's going to happen here. And this is actually Ford's solution for the cracking. So we know that there's more R&D in it versus me just going, yeah, there's no slot, it's not going to crack. You know, Ford obviously put some time into it. Probably not a lot because it's Ford, but they did put some engineering time into it, and they addressed the cracking issue. So that's a bonus for us. You know, now we have a solution or a fix for a non-sleeved block that we can throw a rod and piston setup in. So I would imagine if we use this and we avoid the cracking here, we have good cylinder thickness or liner in here. I don't know how thick they are. I would have to chop one of these blocks up, and these are a little bit more expensive, so I'm probably not going to do it. We're just going to have to throw a rod piston setup in it and send it to the moon and see what happens. But the cylinder itself that the liner is actually going into is thicker, so that's a bonus. However, we do have some issues with using this block, which I'm going to address once we get the car up and running. And we're going to go over that here in a sec. But everything deck-wise is the same as the 1.6. The difference is there's some better drain back improvements. So if you look here, this is actually tapered. You probably won't be able to see it on the camera, but this is actually tapered down into the drain backs, and this is on all the drain backs. Well, actually, there's only two, so it's on both drain backs, there and there. We have a little bit of different bracing that comes in here. It's not much different. I think it's just they might have changed the tool path to make machining easier on their end. So there's really not much difference over here. There's differences on the gasket. I can set the two gaskets next to each other, wherever the hell it's at. I probably threw it away. Yep, I did. Oh, excuse me. Burped. So that is probably not correct. Anywho, I line these things up. The 1.5 actually has more cooling flow through on the gasket itself. I mean, you can see up here, there's none. Down here, there's 3. So we're actually, and even on the side, we're going to have coolant going through the cylinder head and the block a lot more than the 1.6 gasket allowed. So in my opinion, this is a better gasket. Additionally, I checked out the layers of it. This one actually has a little bit thicker layers too. So I might actually use this. Even if we use a 1.6 block, say a sleeved one, we might use the 1.5 gasket, because this is actually a decent gasket. And with us, well, I haven't shown yet, but we're going to be O-ringing the heads just like we do in the 2023. With this nice thick gasket here, that O-ring will dig nice in there, has a ton of room on it. So I think we have a solution for a head gasket using this. We'll also throw our coating on this like we do with the 2023s. And that helps out a little bit. So back to 1.5 block and the differences. The biggest difference is going to be thermostat housing. This has a weird ass plastic one that just slides in here. There's a little O-ring in here and has a stud holding it. That's it. I mean, it's rigid. It is what it is. But the cooling outlets are way different. So I'm going to go grab well, you can see here, this is casted in, and we have a piece that bolts to it that holds the thermostat. So sorry for the mess. We're waiting to get into our new shop so I don't have to keep using my personal shop. This is actually my shop for my own cars, and there's not a single one of my cars in here. Well, I guess the Fiesta is the company's, but when I mean personal, I mean my actual personal vehicles. So thermostat housing, here it is. I'm going to show the vast difference between the two. I'm sorry, this is going to be a long video, but hopefully it's informative for you guys. So this will bolt on there. You see we got a solenoid on here. We'll talk about that in a sec too. So this bolts on here normally on the 1.6 block, and you can see that's different. We have the lower radiator hose here on the right side on that engine, and then we have this solenoid here, coolant bypass solenoid, This goes down to the oil cooler. And then, well, my camera idled out. Boop. And then we have this port going off the side, and this goes up to the other side of the head where there's actually another coolant bypass valve. So, setting this back, well, sitting in the trash, I looked up a schematic and a detailed outline of the cooling system for the 1.5. So, lower radiator hose, that one off the 1.6 should still fit. So it's just going to be a little bit further over, and because the lower radiator hose kind of comes down like this and swoops this way, it's still going to connect. And then what we have here, this is the upper hose, the one that goes up over here to this solenoid. So we'll make that work still. We're going to put it up here on the solenoid on the 1.6 head. And then this one here is actually a little different. This one goes down to the cooler. That's the same as the 1.6, but where it's different is this actually splits off, goes to the degas bottle as well, or degas bottle. I call it the dingus. But this splits, goes to cooler, splits, goes to the dingus. And then this also on the 1.5 has another split that goes to the intake manifold. So we're not going to get into that, where it's going to be another video, but this one on the 1.6 is only going to the oil cooler and the dingus. So what we're going to do here actually is we're going to buy a Fusion coolant line for here. So the Fusion coolant line, it'll have that extra port on it. We're just going to plug it for now until I do some more testing, and then later on we might use it for something else. But this will go to the dingus. This will go down to a blocked port, and this will go down to the cooler here. So the bypass valves, what they're used for is actually to warm up the engine to reduce emissions. So when the engine's cold, the cylinders are not hot, so a lot of raw fuel gets out the exhaust, goes into the cat. So what Ford does in two parts is they block the coolant from flowing through the system, through the radiator, through all the heater core, blah, blah, blah. They actually block it, and they slowly open the bypass valve that was here and the one that's up here. I'm just pointing to nothing, but there is one up there. It's on the side of the head, as if the head was bolted onto it. Those block it. Coolant doesn't run through the engine. Engine warms up faster. Emissions are reduced because the cylinders are brought up to temp faster and allowed to efficiently burn the fuel. And then on the ECU side, to warm up, they actually do what's called split injection, and they have another thing that's called CSER, which is cold start emissions reduction. Essentially what it does is just yanks all the timing out of it, and we're talking like 15 to 20 degrees negative timing, and that allows a hotter post burn, and then you get a hotter cat, which in turn will burn the raw fuel that's going through there more efficient. So it's all emission systems related. So with us losing a bypass here, it's not that big of a deal because it's not used when the car's 100% warmed up. So we're going to retain the coolant bypass valve that's up here, and we're gonna leave it plugged in. This one's not gonna be plugged in. So what I actually did is I had the guy that's actually buying this Fiesta, the trash Fiesta, he has a Fiesta he just sold, but he still had it. I had him unplug the bypass valve here and go drive the car. So that would keep it closed. So I told him not to drive it long because I didn't know if it was gonna be hindering the ability to cool the engine down. I don't think it would because it's still circulating through the radiator, circulating through the upper portion here. You know, it's just one block section, so not a big deal at all. So he drove around, didn't get a check engine light, didn't have any issues at all, got up to temp just fine, no issues. So we know that we can delete this valve and not run into a check engine light. Mind you, he did only drive it for 20, 30 minutes, and he checked on the access port to make sure it wasn't a hidden code, and it wasn't. I did some research on the back end in Ford's dealer, their workshop, and they didn't really connect any DTCs to it, which is a check engine light. So we should be fine there. So basically all this block's gonna really need is, obviously we're not gonna buy this with the 1.5 stuff in it. It's completely empty. And we're gonna put the 1.6 crank in it. Our rods, our pistons are going to go in there, and we're going to have a built 1.5, but is technically a 1.6 because the bore is the same, deck's height, or the deck height's the same. We're just getting the 1.6 displacement back by using the 1.6 crank. So we should be able to use this block. That'll solve our issues. Hopefully we'll be able to push these block a little harder. I imagine, because we're pushing these things, stock sleeves to 650, 700 if you want to get spicy. And these are basically a cylinder, same cylinder design. You know, it's open. well, actually, technically, that's a semi-closed deck block. That's the different block that we use. So technically, we're using different blocks from Ford in the wrong vehicles, essentially, because they're better. I don't know what Ford was thinking, but is what it is. So we got a semi-closed deck, open deck. We can add CSS to this. This is Daniel Newman's car. He has a CSS with sleeve liners in it. I have a picture. Maybe I'll throw it in the video here. But anyways, we can add CSS to this and add some rigidity to the outside of it. But I think as it sits, because it's a low displacement engine and the cylinder head ports are so small, and realistically, even if I take that cylinder head and I hog it out like crazy and try to get more flow out of it, it's never going to flow enough air to really make big power. So the displacement really kills it too, because to make big power, you need a ton of airflow, which requires a big ass turbo. That's fine when you're running one of these guys, but when you're running this little itty bitty displacement 1.6, it doesn't have enough energy to spool that turbo. So if we take this thing and we sleeve it and we port the head out and O-ring it and big ass 1/2-inch head studs, blah, 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 do the works on it. And then we're like, oh yeah, we're gonna put a 6870 on it from Precision. I will die before this thing makes 25 pounds of boost, you know? So we're looking at other solutions on that too. I do have a custom crank that's being made and actually should be shipping next week. We'll show that in a different video. But if we can get some more displacement out of it with some changes that we make to that block, maybe we'll have a 600 horsepower Fiesta on our hands this year. But there's still a ton of R&D to do. You know, this is just the first step here, you know, getting this block to function, get in the car, run, drive, make sure there's no cooling issues, make sure that, you know, everything fits and works. You know, that's the first step. So right now, we have a lot of customer cars going on. So we have this car here that needs to be done. This was worked on by somebody else. We brought it here. It was a huge clusterfuck, basically, and this thing's getting torn down. So we need to assess what's going on here and do that. We have the trash Fiesta. We have Daniel Newman's car. So this car right here is getting put together next week. This one is sleeved, has a CSS added to it, still a 1.6 block, because I was trying to save as much money as possible because he was screwed over by another. Well, my camera decided to stop recording, my bad. But anyways, he got screwed over by another company, so we're saving some money. But the big issue with this, you know, is to do these right, we need certain things to be done for us. So rods, pistons, we had made, we designed the pistons. The rods are an off-the-shelf rod you can get, but we've had them make a couple changes. And realistically, the major change that really matters is the bolt that we're gonna be using. So the biggest headache, and which took a long time, is the bearings. There's no aftermarket bearings for these things. So we are using OEM, which are actually quite nice, surprisingly. And I really never had any issues with a Fiesta having a bearing failure. Maybe if you start with oil, what have you, but the bearings are actually quite thick. You can see them here. The mains are still in. They're super nice, but they come in 50 different sizes and you have to kind of figure it out. So, but we got these cars here. We have a Mustang being dropped off. Whoa, ceiling. Anyways, we have a Mustang being dropped off on Monday. We have another Focus RS getting dropped off. And then we have 8 other cars coming here for builds over the next couple months. So that's why we're getting the hell out of my personal shop, getting into a big shop. So 5,200 square feet, biggest shop we've had yet, bigger than our shop in Texas. But yeah, so we have a new shop. We're gonna start assembling the trash Fiesta on the side. I can't actually sell this thing until we get the title for it, which, because this was a rebuilt car, we have to get it inspected. And with COVID-19, the inspection place is closed. So we have about a month and a half before that thing needs to go together, which will be fine because we need to get our new pistons here. They're all designed and everything. We used to get them machined, but 2023 pistons are priority right now because we have 18 engines on the queue for 2.0 and 2.3. That's Focus ST, Focus RS, and Ecoboost Mustang. And we got 2 of those engines going to a guy that builds trophy trucks. And we're doing some trophy trucks with our engines in them. So pistons for the 2.0, 2.3 right now are priority. But I do have a set of our previous custom pistons that we had made for the Fiesta already. What's going in Dan's car, what's going in this block here. So that's just kind of what we have going on. So you probably won't see a Trash Fiesta update for a couple weeks because we are waiting on a crank. I think I mentioned that earlier in the video, but once the crank gets here, test fit with it. If it's going to work, we're going to build another block for our other Fiesta we bought, and this one will go back together as a 1.6. So yeah, Fiesta updates, give me a couple weeks. The next videos to come are going to be probably tearing down this engine over here that's sitting on the stand. Once we get that torn down, we are going to inventory everything we have for it, what needs to be replaced, what we need to order for it, get the customer updated, get him to send his deposit in, and get that car going. And then that Mustang will be on the next couple of videos as well. That's a huge build. I'm not really going to get too far into it, but it's going to be probably the highest horsepower Ecoboost out there. So the engine's actually in there and the cylinder head's in there. It's going to get sent out. So we'll do a video on that as well. And that's pretty much it. So I think we covered everything, and I don't want to make this video any longer because most of the time people get sick of hearing me halfway through the video. So see you later.